Author and international speaker, Jay Seegert holds degrees in both physics and engineering technology. As founder of the Starting Point Project, Jay passionately seeks to help people establish a biblical worldview based on the authority of Scripture. For more than 30 years, he has been graciously tackling tough questions regarding the Christian faith, especially in the often intimidating world of science, bringing it down to a level that everyone can understand. We trust you will enjoy this presentation as Jay delivers a fascinating talk entitled Evolution, Probable or Problematic?
Well, thanks for joining us for this presentation. You know, no matter who you are or what your background might be, I think you're going to find this information to be fascinating. The creation evolution issue is certainly hotly debated, often producing more heat than light, but we're going to take a rational look at this particular topic. First of all, doing kind of a broad overview, looking at how evolution allegedly works, and then we're going to get into the intricacies of DNA, specifically looking at how the information is structured there, and that's going to help us determine whether evolution is truly probable or more so problematic. Now, this debate really causes a lot of people to struggle. I mean, we're told that evolution is an absolute fact. Nobody doubts it. All scientists believe it. It's been proven by evidence from virtually every area of science. Now, is that true? Or is that just what we're supposed to believe? And what about the creation account as found in the Bible? That seems in stark contrast with what we hear in the public school system and the state universities. And it actually causes a lot of people to walk away from their faith, wondering like, well, what am I supposed to think? Maybe there are some problems with Genesis. Maybe there are some errors or contradictions, or maybe it's not meant to be taken literally. Maybe it's just a story or an allegory. Well, again, these thoughts cause a lot of people to eventually walk away from their faith, which is a huge issue, which is why we're talking about this particular topic. It's really not about proving creation or disproving evolution. It's not like when you get to heaven, God's going to look at you and say, hey, did you believe in evolution? And you say, no, I didn't. Okay, come on in. That's not what it's about. This is really ultimately about the authority of God's Word. Can we trust it from cover to cover or not? That's why we're talking about this particular issue. Now, I want to give you a little bit of background for this particular presentation. I was invited to attend a bioinformatics symposium at Cornell University, which is in New York State. Bioinformatics, what's that all about? Well, bioinformatics is the study of information in living things. This was 27 lectures in 3 days. It was intense. So the world's leading scientists had gathered there. It was not a creation conference. They weren't there to discuss the Genesis creation account or the Bible or even religion. It was solely focused on the science of information in living things. And so I attended the symposium, took a lot of notes, and flew back home to Wisconsin, and I put this talk together. And then I contacted Dr. John Sanford from Cornell, who actually was the one who hosted this symposium, and I said, hey, if I come back out to New York, could I spend a little time with you picking your brain and making sure that my presentation was accurate? I had met him about a year earlier, and he's the one who invited me to attend. So I said, sure. So I went back out there and spent about 2.5 days with him discussing this information. And he said, yeah, it's accurate. And so I put this talk together, and then he also eventually invited me to be on the board of a group that he created called Logos Research Associates. It's a consortium of some of the world's leading scientists who are all committed creationists and committed Christians studying scientific evidence for the authority of the creation account as found in the Bible. So that's kind of the background for this particular talk. I've got a question for you. Have you seen Are You Smarter Than a Fifth Grader? No, you probably have, and it's a dangerous show to watch because you might find out that maybe you're not smarter than a fifth grader. Well, we're going to change this up a bit and ask, are you smarter than a PhD scientist? Now, most people would say, well, of course not. I mean, those guys are brilliant. But I honestly think that after you hear this presentation, you really will be smarter than most PhD scientists when it comes to the creation-evolution controversy, because most scientists, as smart as they are not studying this. This is not their area. They're making rocket fuel, food preservatives, computers. They're doing great stuff, but they're not studying this. They assume that it has been proven. Other scientists are looking into this, and it's good enough for them. But this is not their area. So although they might be very intelligent in their area of study, they don't know that much about the creation-evolution controversy. So after you hear this presentation, you will be better suited to discuss the creation-evolution controversy than most PhD scientists. Now we need to define our terms a little bit better here, because the word evolution specifically is used in so many different ways. For instance, they'll talk about the evolution of the phone, how it's changed over time. And yes, it has changed, but it didn't change by accident. It was designed, but they will call that evolution. Now, I actually don't have a problem with that. If they want to call that evolution, that's fine by me, but this is not what I mean by evolution, and it's certainly not what they teach in the public school systems and state universities. I'm also not talking about different varieties of dogs that we have. There's probably about maybe 250 breeds of dogs on the planet right now. We see this all the time. We also see many different types of cats. We also see different beaks on finches that Darwin got very excited about. These are facts of science. Nobody denies these things. We can all see those things. But these have nothing to do with evolution as taught in the public school systems and state university. This is what I'm referring to by evolution. That supposedly about 3.8 billion years ago, there was a single-celled organism that slowly evolved into every other life form on this planet on its own over millions and millions and millions and millions of years. This, I personally believe, is a story that's taught about the past, because again, no one was there to observe that. We can't reproduce it in a laboratory, and we can't test it directly. So it really is the story of evolution. We also call this molecules to man evolution, that dead chemicals somehow came together to form a living cell, which then changed itself into every other life form, including human beings. And I would actually highly recommend using this phrase when you're discussing creation and evolution with someone, particularly if you don't believe in evolution. Otherwise, if you say you don't believe in evolution, they're going to think you're saying you don't believe in change, and they're going to think you're crazy, because we do see change all the time. So you might want to say you don't particularly buy into the story of molecules to man evolution. Now, I do have some other advice that I would highly recommend as well when getting in these conversations, and that would be ask a lot of questions. Too often we get in these scenarios where someone says they believe A, B, and C, and we set out right away to prove what we believe, and it can kind of get kind of tangled and heated. So what I would recommend is actually listening to what the other person is saying, so that you're better positioned to ask questions. So if they say they believe in evolution, just ask them, what do you mean by evolution? So again, we can get our definitions on the same page. And then you could ask them, how do you know that evolution is true? And they might say, well, it's an absolute fact. I mean, all scientists believe it. Then you can ask another question. How do you know that all scientists believe it? Well, all real scientists believe it. You can ask another question. How do you define a real scientist? Well, anyone who believes in evolution, they're a real scientist. So now we got some circular reasoning going on here. Also, you could ask further questions. You're very confident that evolution is true, and I appreciate you sharing your ideas with me. Could you tell me some of these evidences that give you so much assurance that evolution is a fact? And then they might say, well, it's proven. There's tons of evidence. You say, okay, then it should be pretty easy for you to give me an example or two. Well, there's just so much. Okay, again, I'm just looking for a couple examples. Well, there's whole books written on it. Go to the library and get a book. So you're telling me that you believe evolution is a fact because there are books written on it, and there are apparently some evidences and facts in the books written by people that you probably never met. So in reality, you're exercising faith that you believe evolution is true because you yourself aren't familiar with these facts, which is fine, but then they shouldn't be telling you it's a fact of science. They have chosen to place their faith in it. And that's just one approach, and you want to be very gracious with that, but you want to get them to realize that they're making a lot of bold statements here without a lot to back it up. Get them to be very specific. I had that experience myself in college when I started really tackling this controversy. I knew what I believed, but I didn't know why. I did happen to believe the Bible and creation, but I really didn't have a defense for it. And as I went around to my different professors, asking them, what are these evidences for evolution? None of them gave me any specifics. I'm not saying there aren't any scientists anywhere on the planet who won't give you a specific, but many of them believe very confidently that it's true, but don't personally have evidence for it. That was my experience. My first professor I asked, physics professor, do you believe in evolution? Oh yeah, I don't doubt it at all. Can you give me some of the evidences? I don't know any. But you believe it's true? Yes. Okay, so I went to my geology professor who was teaching a lot of it in his class. Can you tell me some of the best evidences for evolution? He said, I don't know. But you do believe it and you teach it? Yes. But you don't know what any of the evidences are? No. Go ask the biology professors. They're the ones who really teach this stuff. Okay. Found the biology professors who confidently expressed belief in evolution as a fact, but none of them would give me any specific examples. So this is a road you want to go down. If they do give you specific examples, that's fine. You don't need to debate it right away. Just write it down. You can do some research. You can contact our ministry and we can help you with that. If they don't give you specific examples, then you can simply point out that they're expressing a very confident belief in something without any specifics to back it up. Now, here's the general premise of this particular presentation. Certain things, like this bright red BMW, look pretty good from a certain angle or certain distance. You would envision opening the hood and seeing this beautiful engine inside. But what if when you open the hood, instead of seeing that engine, you saw this? The engine is missing. A bunch of wires are hanging there. So what looked pretty good at first glance, upon closer inspection, didn't look so good anymore. And I think that's what we're going to find with evolution. That certain portions of the story seem pretty believable, but when you peek under the hood, specifically look at the DNA to see what's going on, you're going to find out there are some insurmountable barriers to the idea of evolution. And if we talk about the plausibility of evolution, certain portions of the evolutionary story seem pretty plausible. Just small changes here and there over millions of years. For example, we got two creatures here. We have a snake and a lizard. These two creatures are not completely different. There are a number of similarities. It doesn't take much imagination to envision some bumps maybe forming on the side of the snake and getting a little bigger and longer and turning into some legs of the lizard. Just small changes here and there over millions and millions of years. It can seem very believable. But again, once we peek under the hood to see what has to go on in the DNA to make these changes, that's where we see a lot of problems. Now, here's a quote from Richard Dawkins. He's arguably one of the world's leading atheists, very outspoken evolutionist, pretty intelligent scientist. I kind of like the guy because he's just out there. He's saying what he believes as a staunch atheist. And here's one of the things that he stated. You cannot be both sane and well-educated and disbelieve in evolution. The evidence is so strong that any sane, educated person has got to believe in evolution. There's a very dogmatic statement from a very intelligent scientist. What are we to think of that? Well, here's another quote. This is Proverbs 18:17. It says, the first one to plead his cause seems right until his neighbor comes and examines him. Now, we've all been in those situations before where you hear something and at first you're like, wow, that sounds pretty powerful. Can't argue with that. But then someone else comes along and says, well, wait a minute. Did you know about this? Did you know about that? What about that? It's like, oh, yeah, I didn't know those things. Okay, I guess that first thing I heard doesn't seem so good anymore. And I facetiously say that Evolution 1:1 states that the only one to plead his cause seems right because no one else is allowed to challenge him or present other views. And that's what we have in our public school system. They're only presenting one view, so of course it's going to seem plausible. Here's another interesting quote from Eugenie Scott. She's the executive director at the National Center for Science Education. She said, in my opinion, using creation and evolution as topics for critical thinking exercises in primary and secondary school is virtually guaranteed to confuse the students about evolution and may lead them to reject it. Wow, how awful would that be if someone actually didn't believe in evolution? So what's she saying? She's saying that we really shouldn't contrast the two here and give the students a choice here between creation and evolution, because they might be confused. They might actually end up believing in creation, and you certainly can't have that. Well, again, when you're presenting only one view, it's going to seem plausible, and you're giving the impression that there aren't any other choices. There's only one game in town. If something else comes up, it will let you know, but for now there's only one, and that's evolution. If you want to talk about that creation stuff, well, hey, that's religion. That's that Bible stuff. That has to do with myths and fairy tales. You can discuss that if you want to, but you got to do that in philosophy class or somewhere else, religion maybe, but not in the science classroom, because science deals with facts, and we know evolution is a fact, so that's all you're going to hear from us. Well, we are now going to take a look just a little bit at the big picture. No matter who you are, whether you're a Christian, an atheist, a Muslim, a Buddhist, a Mormon, your worldview, meaning the way you look at things, has to address a number of very basic questions. One of which is the origin of stuff. Where did everything come from to begin with? How do you get matter and energy out of nothing? Interesting topic. We actually cover this in more detail in one of our other presentations. But how do you get all this matter and energy to come out of nowhere? Huge, huge problem. Another big question is, once you have stuff, matter and energy, how does it form stars, galaxies, and planets? The laws of physics actually mitigate against that, and again, we cover that in more detail in a different presentation. Once you have stars, galaxies, and planets, how do you get dead chemicals to come together to form a living cell that could actually reproduce itself? This is one of the biggest challenges to the whole big picture of evolution, is how do you even get life started? Then once you have life started, how does it turn into every other life form on this planet? The variety of life, the origin of species. And that's actually what we're going to focus on for this particular talk, is the origin of species, the variety of life. How do you get that single cell to turn all the way into a human being over the supposed 4 billion years of evolutionary history here? Well, there's a lot of arranging and storytelling that goes on when discussing evolution. As an analogy, I've got 4 modes of transportation on the screen here, and we could arrange these things from simpler to more complex and talk about the evolution of the motorcycle, how the smaller wheels on the tricycle came together to form the larger wheel in the back of the bike, and then the chains in the back of the bike moved forward to turn into an electric motor of the scooter. And then the electric motor moved further forward and turned itself into a gas combustion engine, and that's how we got motorcycles. Now, that's a pretty silly story, and no one would believe that, but all I did was I took some existing things, arranged them from simpler to more complex, and talked about the evolution of the motorcycle. And similar things occur when discussing evolution. As an example, we could talk about the evolution of the horse from Eohippus all the way up to the modern horse. Well, here's an interesting quote from Dr. Niles Eldredge. He's a former curator at the American Museum of Natural History, big-time evolutionist. This is what he had to say about this situation. I admit that an awful lot has gotten into the textbooks as though it were true. For instance, the most famous example still on exhibit in the American Museum, that's his museum, is the exhibit on horse evolution. That has been presented as literal truth in textbook after textbook. Now I think that that is lamentable. But by the time it filters down to the textbooks, we've got a problem. Well, what's he saying? He's saying, well, yeah, we know it didn't actually happen, and it probably shouldn't be in the textbooks. Well, if it shouldn't be in the textbooks because it didn't happen, why is it okay to have it in the museum? Think about the millions of students who file through that museum, and adults each year, seeing these fossils lined up and seeing the little plaques there with the story of how Eohippus evolved all the way into the modern horse. Well, it's pretty sad when they know it didn't happen, and yet they keep it there as evidence for evolution. We're going to look at one other analogy. This comes from the Book of Life. The general editor is Stephen Jay Gould. He was one of the world's leading evolutionists, and this is what he portrayed inside the book: the evolution of fish into amphibians. How fish slowly evolved over millions and millions of years into something like an amphibian. Well, what did it look like in the middle? It's what we call a missing link. But it's not missing anymore. They found it. It's tiktaalik. found another fossil here. That's the missing link, right? Well, it's already pretty much been thrown out because they've discovered some fossil footprints of four-footed creatures that evolutionists believe existed millions of years, according to their time chronology scenario, millions of years before Tiktaalik was here. Well, if four-footed creatures were already around walking this earth, then Tiktaalik is not on its way evolving into one of those because they already exist. So that's pretty much already been discounted. But this type of scenario isn't much different than doing this, talking about how an Etch-a-Sketch evolved into an iPad. Well, what did it look like in the middle? Well, use your imagination, maybe something like that. A little bit like the Etch-a-Sketch, a little bit like the iPad. These two things are not completely different, so it doesn't take much imagination to envision these changes. But you know there's no way that the simple internal workings of an Etch-a-Sketch are going to turn itself into something as complex as an iPad over time. It's just not going to happen. And again, that's what happens when you think about what's going on inside. So how do we make this transition going from a single-celled organism all the way into a human being? Well, when we reproduce and have children, our kids don't come out looking exactly like us. There are some similarities. They might have similar hair color, similar eyes, but they're not identical. Changes do occur. There's no denying that. What are these changes? Well, we see two types. We see built-in variation and we see random mutation. Built-in variation has to do with the genes inside of our DNA. Certain portions there that code for different things in our body. We're getting a pretty good idea of how that works. The random mutation, that's a little different. Those are accidental copying errors. They're accidental. We don't know what to expect. So those are the two major types of changes that we're going to be discussing. We're going to start out looking at the built-in variation. Now, I've got two dogs on the screen here. They both have medium-length fur. And they each have two copies of the genes that make fur length. Why do they have two copies? Because they get one from mom and one from dad. So they got two copies of these genes. When they breed, they will each pass on one of those copies to the puppy. They don't get to pick or choose which goes, just one goes or the other. If they both pass on a copy that makes short fur, the puppy comes out with two copies, both making short fur. The puppy will have short fur. Doesn't matter which gene is expressed or if they combine together. It's going to have short fur. If they both pass on a gene for long fur, the puppy's going to come out with long fur. Doesn't matter which one is expressed or they combine, you're going to have long fur. Thirdly, if they pass on one a gene for long fur, the other a gene for short fur, the puppy can come out with medium length fur if the genes combine, or it could have long fur or short fur, depending upon which gene is expressed. This is how genetics work, and it explains the variety of fur length we see in dogs. But genes don't just do fur length. They do all the features we see in dogs. We've got big dogs, small dogs, long ears, short ears. All the features we see are pre-coded in the genes in the DNA. Now, you can ask yourself, which set of these animals looks more similar to each other, set A or B? That's pretty obvious. The animals in set A look a lot more like each other than set B. Why is that? Because the animals in set A are really the same kind of animal. The Bible says in Genesis chapter 1, 10 times in 5 different verses that God created creatures to reproduce after their kind. Can they produce a nice variety? Oh yeah, but always within limits. In fact, today, dogs, dingoes, coyotes, and wolves can all breed together. When you breed a dog and a wolf, you get a wolf dog. It is no surprise. This is real science. Looks a little bit like the dog, a little bit like the wolf. That's what we would expect. But you can't breed a dog and a wolf and get an ostrich. That's not possible because they don't have genetic information to make beaks and feathers. There are some other animals you can always breed together. That's a zebra and a donkey. You get a zonkey. Kind of funny, but why is this possible? Are these completely different animals? No. Basically the same animal, one just has a nice paint job. You can also breed a lion and a tiger and you get a liger. Why is that? Are they different animals? No, they're the same kind of animal. They're basically large cats, so that's why this happens. But again, you can't breed a lion and a kangaroo to get a lion-garoo. That one's not going to happen because they're not the same animal. There are some other animals we're also not going to get. It would be these here. This is what happens when you have Photoshop and too much time on your hands, of which I have neither. I didn't do these. They're kind of fun to look at, but it's obvious that this isn't going to happen because they're not the same kind of animal. Well, that was the built-in variation. We are going to, in part 2, take a look at random mutations. And this is where it starts to get really interesting. Business picks up quite a bit. So we hope you can join us for part 2 of this presentation, where we will peek under the hood to see what's going on in the DNA, specifically how is the information structured there. Can we make random changes to it with mutations to make things better and better, or are we going to make things worse and worse? So join us for part 2. God bless. Now, we did cover the built-in variation in part 1. Part 2, we're going to be specifically focusing on random mutation. Random mutations are accidental copying errors in the DNA. When the DNA copies itself, some mistakes happen, and that's what we're going to be looking at more specifically in part 2 here. Now, here's interesting information about random mutations. This is from University of California, Berkeley. They said mutations are essential to evolution. They are the raw material of genetic variation. Without mutation, evolution could not occur. So they're telling us that mutations are critical. You've got to have mutations, otherwise you can't have evolution. Very, very important for evolution. Well, they also say mutations can be beneficial, neutral, or harmful to the organism. Well, theoretically they can be, and that's a whole other talk to talk about beneficial mutations and some of those details, but we're going to be looking specifically at these mutations in general. Are they going to improve things and get better and better, or are they causing insurmountable problems for us? Let's talk just for a moment here about error correction. Again, these mistakes are happening in the DNA. Well, the DNA actually has the ability to correct these mistakes, which is interesting. In fact, we see that on a good day, about 1 million bases in the DNA in a human cell are damaged. These bases, basically, we're going to be talking about the rungs in the DNA here. 1 million of them are damaged every day in our cells. We've got up to about 100 trillion cells in our body. So a lot of damage is occurring, and it needs to be corrected or we couldn't function or even be alive. Well, what's interesting is these very elaborate error correction systems are actually coded on the DNA. You need DNA to make those error correction systems, but you can't have DNA surviving without them. So it's the classic chicken and the egg scenario here. Which came first, the chicken or the egg? Well, which came first? DNA with all its complexities, or the error correction system to correct these mistakes? You can't have one without the other, but you can't evolve them over millions of years by accident. They need to both appear at the same time. Huge problem for the whole idea of evolution. We're going to talk next how evolution allegedly works. So we are now going to be transformed into a state university science classroom, and I'm going to be a PhD molecular biology professor telling you how evolution works. And this is how it goes. We've got a single-celled organism up here that's going to reproduce itself. So it needs to copy its DNA. So it does that and produces children. And you can see the children look pretty much like the parents because it's a copy of the same DNA. Then the children reproduce, and we now have grandchildren that look pretty much like the parents and the grandparents because it's a copy of the same DNA. And then the grandchildren reproduce, and oh, we got a problem going on here. We got some serious mutations. Some of them apparently are bad, others apparently look like they might be good. Then natural selection comes along like a superhero and wipes out the bad mutations and tends to keep the good ones. And then reproduction continues. and the new good ones reproduce themselves, so we have more of the new ones, and then the original ones continue to reproduce, so we have more of those as well. Can you imagine the great variety of life we would have on this planet through this process happening over millions and millions of years? Now here's the point. I believe that the non-Christian students sitting in this classroom, hearing that presentation, think to themselves, makes perfect sense to me. You can't argue with that. I mean, this is my PhD molecular professor, telling me about all of this. It's a fact. This is what scientists have proven. You could see it for yourself. But I guarantee you, the Christian students sitting in that classroom see that and they say, it makes perfect sense to me too. I guess the Genesis creation account isn't correct, wasn't meant to be taken seriously. Maybe there are some errors or contradictions. And many of them end up walking away from their faith due to that and other factors going on. Well, we are now going to take a closer look at these mutations. Some of you are familiar with Paul Harvey, a famous radio announcer. He was famous for telling us the rest of the story. And that's what we're going to look at next, is the rest of the story regarding these mutations. Can they do what evolutionists tell us they do? I'm going to make 3 major points about mutations. First of all, that they are random, purposeless, and undirected. Secondly, that they occur in the DNA. And thirdly, that they're almost entirely detrimental or bad. We're going to start out looking at the first point, that they are random, purposeless, and undirected. Here's an interesting quote from Nova Online. This is an evolutionary source. This is what they had to say. It's sometimes convenient when trying to make sense of evolution to think of changes within a species of having a purpose, as though Mother Nature has some intended goal that she sets out to achieve. The bacteria want to survive, someone might reason when thinking about the declining effects of antibiotics, and so they evolve into resistant strains. Of course, there is no purpose in evolution, just random mutations within the DNA, most of which are detrimental to the survivability of the organism. Those are the 3 points that I just made on the previous slide. They're random, there's no purpose to them, they're occurring in the DNA, and they're basically bad. Very interesting. Well, here's another interesting quote from Discovery News talking about dinosaurs. Presumably the sauropods evolved large body size as a strategy to deter predators. Well, what are they saying here? Well, apparently it goes something like this. At some point in history, dinosaurs weren't as large as they eventually came to be. So they're sitting around the campfire one night and they're talking, saying, hey, you guys, we need to come up with a strategy to deter our predators. Otherwise, we're going to go extinct much sooner than we're supposed to. Do you have any ideas? They say, no, our brains are too small. And one of them says, I got an idea. What if we get some machine guns? We could shoot our predators. First dinosaur says, no, we can't do that. They haven't been invented yet. It's like, okay, good point. Second dinosaur says, I got an idea. What if we hopped onto our motorcycles? We could ride off into the sunset. First dinosaur says, no, they haven't been invented yet either. Third dinosaur says, I got an idea. What if, just what if we evolve really large body sizes, we could scare them away? First dinosaur says, now that's a good idea. Are we all in agreement? Okay, break. And they go off and they get big. I don't know a scientist on the planet who believes that. They don't believe that a creature needs something and so it evolves it. But we have a problem with the popular literature. Often they'll talk about the fish swimming around in the oceans millions of years ago, and then food started to become scarce. And so they needed to evolve lungs to crawl up onto land to find new sources of food. And the students write it down. Makes sense to me. I mean, they got to do something. They're running out of food. They're going to die if they don't do that. But here's the question. How do fish even know what lungs are? I know they swim around in schools, but even if someone taught them what lungs are, what are they going to do about it? All they have is genetic information to make gills and other fish parts. And even if they could try, how are they going to survive over millions of years as their gills stop working underwater, but they can't breathe air yet up on land? They're not going to be able to survive. The scenario doesn't make any sense, but often the students They don't really even have time to think it through. And all they know is they have to pass this test, to pass this class, to get a degree, to get a job, to live in the real world. So what do they care? Just put it down and move on. It doesn't matter one way or the other. And that's typically what can happen in the university setting. Well, that was the first point about mutations. The second point is that these mutations are occurring in the DNA. So we're going to take a very quick look at DNA here. DNA is like a very, 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 very complex blueprint with lots and lots and lots and lots of information on it. So let's take a look briefly at the storage capacity of DNA. Let's say you had just a teaspoon amount of DNA and wanted to back up that information onto CDs. And we back up our computers once in a while in case they crash. So we're going to back up that information on CDs. Now, a single CD can hold about 100,000 pages of text on it. So how many CDs would we need? Well, you would need 100 CDs, but don't write that down because that's not true. You would need 1,000 CDs, but don't write that down either because that's not true. You would actually need 1 million CDs, and that's only partially true. You would need 1 million CDs given to you every minute for 9.5 years. Then you'd have enough CDs. That's 5 trillion. Might give you an appreciation for our national debt, but that's amazing. But you know what we're taught? Oh, that's just an accident. Just particles smashing together. Nature created that elaborate information storage system. Well, here's another look at DNA. DNA is like a very huge set of complex information that we would find in encyclopedias. In fact, the letters inside the encyclopedias are represented what we call nucleotides. Those are the rungs on the ladder. So each rung is like a single letter out of that whole set of encyclopedias. Then when you group a bunch of rungs together, that's how we form words. You group letters together, you get words. You group these rungs together, or nucleotides, and that's how you get words. When you put thousands or tens of thousands of these rungs or nucleotides together, that's how you create a chapter out of the set of encyclopedias, which is what we call a gene. You're familiar with the term the gene in our DNA? Genes are chapters in the set of encyclopedias. Then when you put thousands of these genes together, that's how you get a chromosome, which is a single volume out of the set of encyclopedias. And then when you take a look at the entire set of encyclopedias, that's what we call the genome. For people, we call it the human genome. That's a little bit of biology 101. Many of you probably already knew much of that, but it's kind of interesting. Now we're moving on to the third point, and this is where things start to heat up, that these mutations are almost entirely detrimental or bad. And again, this is where I think it gets really interesting and where you can really make a decision. Does evolution seem probable or problematic? Now here's how the story of evolution goes, and I say story not to be derogatory or condescending. It truly is a story of what they believe happened in the past, because again, they weren't there to see it happen. They can't reproduce it in a laboratory, and they can't really test it directly. So it's their story of what they think happened millions and millions of years ago. As part of this analogy, let's say that the amount of information in a single cell bacteria is about the amount of information we find in a biochemistry textbook, which is true. The amount of information is equivalent there. But remember, we need to change that single cell all the way into a human being. So we can't just copy it, we need to make changes. So continuing our analogy here, I'm going to use this book here, Biological Information, New Perspectives. This was birthed out of that bioinformatics symposium from Cornell University. This is the information that came from the 27 lectures that were given during that time. We're going to look at just one page, some sample text here, highlight some of the text, put the text off to the left, but we can't just copy this information. If we just copy this over and over and over, millions of years from now, we'll just have a lot more of these textbooks. We've got to change it. Well, what are these changes? The changes are the mutations that we've been talking about. So let's look at some example mutations. These will be point mutations. First of all, we have a duplication mutation. We take the ending L in level and we duplicate it. There's an extra L there. It no longer spells level. But I know what you're thinking. If you were reading that, you'd say, oh, it's just a typo, and it's level, and you'd move on. That's not how our genes work. Our DNA would see that and say, I don't know what this is. I've never seen it before. It's meaningless. And it would move on. It destroyed that piece of information. Another example of a mutation is a deletion. We take the M out of the word model. It doesn't spell model anymore. Third example is a substitution mutation. We take the P out of probability and put a Z in there instead. It doesn't spell probability. These are examples of point mutations. Now here's where it gets kind of interesting. You could ask a kindergartner, what is your favorite book? And they tell you some book. And then you ask them, if we took your book and just randomly opened it, closed our eyes and stuck our finger in there, and whatever letter we touch, we just delete it. And then we open it up again and stick our finger in somewhere else, and we duplicate that letter, put an extra one in there. And then we open it up again, and we touch another letter, and we take that letter out and just put another random letter in there. And we just keep doing that. What would happen to your book? Will it get better and better and better? A kindergartner will tell you, no, it's going to get worse and worse. In fact, I won't even be able to read it after a while. A kindergartner understands this. You have to be highly educated to not get this. And again, I don't want to be condescending here, but that's often what happens. These scientists are plenty smart. They don't need more information. They need a different starting point to use to interpret this information, because facts don't speak for themselves. So these scientists are plenty smart, but many of them aren't even aware of this, and those who are hoping that someday they'll find an answer. They have faith that someday they'll figure it out, but right now it is a huge obstacle for the idea of evolution. But the challenge for evolution gets much worse than that. Everything we've already covered here, it's going to get much worse as we think this through, specifically looking at the DNA and talking about how the information is structured on the DNA. We're going to be looking how information is written. We're familiar with how books have information. Now we're going to look at how information is structured on the DNA. So as an example, let's say you were looking at your DNA and it spelled out, was it a rat I saw? Kind of a strange phrase here, but we know in English that we read from left to right. You may have already noticed, you can actually read this backwards. Was it a rat I saw? It's called a palindrome. Read it forwards and backwards. It's kind of fun, again, not very meaningful, but it can go both ways. This is what we've discovered about our DNA, that much of it can not only be read forwards, but it can also be read backwards. But guess what? The challenge for evolution gets worse than that. Take a look at this phrase here, desserts. We flip this around, and it spells stressed, which is what I get when I don't have desserts. Now, let's introduce one of our random mutations here. We'll just randomly delete the T. It doesn't spell desserts, but it also doesn't spell stressed. One random mutation messed up two messages because they go forwards and backwards. But we don't see just little words that flip back and forth in our DNA. We actually see up to entire chapters of complex instructions that can be read forwards and backwards. And let me give you an analogy so you understand how challenging this actually is. Let's say you have a job working in a smartphone factory, and it's your training to write the instruction manual to give to the manufacturing plant for them to make the phones. Your boss comes to you one day and says, I got a project for you. I need you to write the chapter in the manual that explains how the phone is going to download apps from the web. You say, yeah, I can do that. He says, okay, thanks. Then he's walking away. He goes, sorry, I got one minor detail I left out here. When you write that chapter, you have to write it in such a way that if we read it backwards, it's going to explain how the phone's going to play music files. And you're looking at him like, I mean, you're kidding. I mean, just being funny, right? And he says, no, I'm sorry. We only have so much room in the manual. It's got to be read forwards and backwards. That is humanly impossible. It cannot be done. You can't even program a computer to do that. I did computer programming for 18 years. It can't be done. But that's what we're seeing in our DNA. We read it one direction, It's a set of complex instructions that make certain proteins that carry out a certain function in your body. We read it backwards, completely different set of instructions that create completely different proteins that carry out a completely different function in your body. Two major points with this. Number one, particles smashing together in nature will never create an elaborate data information system like that. And number two, when you make random changes to that, you're not going to make it better and better. It's going to get worse and worse. But the challenge for evolution does get even worse than that. We have overlapping information in our DNA. Take a look at this strange phrase here, I like choco later that evening. Why is it strange? Because it's two phrases. I like chocolate, which is true, and then later that evening. The two phrases overlap. And the four letters in the middle, L-A-T-E, they share those letters. This is what we've discovered about our DNA, that we've got overlapping messages. Well, let's introduce a random mutation here. We'll just randomly take out that E and put a Z in there. It doesn't spell I like chocolate, and it doesn't spell later that evening. This is what we're seeing in their DNA, overlapping messages. But we don't see just a few letters that overlap. We see up to entire chapters of complex instructions that actually overlap each other. It is absolutely amazing. But the challenge for evolution gets worse than that. We have spliced information in our DNA. Take a look at that same phrase again, I like chocolate later that evening. Let's underline a few portions and then bring them down below. It spells, I like her hat. This is a spliced message. Let's introduce one of our random mutations here. We'll just randomly delete the H. It doesn't spell I like chocolate anymore, but it also doesn't spell I like her hat. One random change messes up two messages because they're spliced, and that's what we see in our DNA. But we don't just see a few letters in our DNA that can be spliced. We see up to long sentences and short paragraphs that can be spliced. What does that mean? This is what it's like. Think about reading that biology textbook. Read the whole thing. You just learned a lot of information. Now you go back and you just take out kind of random long sentences and short paragraphs from different places in the book, put them together. Now you have another set of instructions. That, again, is humanly impossible. You can't do that. You can't even program a computer to do that, but yet that's what we're seeing in our DNA. But guess what? The challenge for evolution gets worse than that. We actually have embedded messages in our DNA. Take a look at this sentence here. Can you show Mike Owen checks from Oliver's latest facts and set it on the desk? Strange phrase. Let's circle every eighth letter here and bring them down below. It spells out chocolate. There's a theme going on here. It's my talk. I can do that. But this is what we're seeing in our DNA. There's actually embedded messages. Now, let's just introduce another one of our awesome random mutations here. We'll delete the H. It messes up the main sentence, but it also messes up the embedded message because what it does is it shifts all the letters after that mutation over one spot. So now if we circle every eighth letter, it would be these letters here, which are completely meaningless. So one random mutation here messed up two messages, the main message and the embedded message. But guess what? The challenge for evolution gets even worse than that. We have encrypted messages in our DNA. I actually had 2 interviews with the CIA to work in their cryptographic analysis division. Very interesting and strange story for some other time. But let's talk about data encryption here. We've got a strange, somewhat meaningless phrase going across the screen here. But what if you found out there was actually an encryption key here, meaning everywhere you saw an H, it's actually an A. Everywhere there's a B, it's actually a C. Everywhere there's a Y, it's actually a T. So these 2 Y's up there are actually T's. If we make all the substitutions, it spells out this is an encrypted message. This is actually what we have going on in our DNA, encrypted messaging. Now let's take just a second to think through what would be required to create an encrypted message system. Keeping in mind that there's no God, there's no creator, no designer. just particles smashing together in nature. And that's basically the crux of what they're teaching in the public school system and state university. Whether the teachers or professors believe in God or not, they're not saying God was involved here, he did this, he did that. No, they're saying we can basically explain everything through science. So what would be required to create an encrypted message system by particles banging together in nature? Well, we'll take a look at this. Here are the steps. Number one, you have to develop a language system using symbols. So when we've got these three sticks here, if we put them together this way, that's going to be an A. And when we have these three shapes that way, we're going to put them together like this, and that's going to be a B. You have to create an entire alphabet by particles smashing together in nature. Step two, you have to create and define words. So when you put these four letters together that way, that's going to represent that object. You have to create an entire dictionary of words and definitions by particles smashing together in nature. And then you have to be able to write meaningful sentences and paragraphs, which actually requires rules of grammar. How do particles smashing together in nature create rules of grammar? Fourthly, you have to establish the encryption system with that key. Fifthly, you have to create the system that does the coding and the decoding. And then sixthly, you have to develop the ability to read and carry out the instructions, or the whole thing is useless. How do particles smashing together in nature do this? I don't know a scientist on the planet who can even begin to explain how this is possible. Yet, by faith, they believe it must have happened. Again, a lot of the scientists aren't even aware that this is going on. Those who are have faith that just somehow it could happen. To me, it makes a lot more sense that this is evidence for design. But the challenge for evolution actually gets worse than that. One last time here. We actually have 3D information in our DNA. I'm actually skipping a few details here. You can thank me for that later. But 3D information. This is a little harder to depict with PowerPoint here. I'll do my best. When DNA makes proteins that carry out all the functions in our body, they're not these little straight ladders. They get folded up into very complex three-dimensional formats. And if they don't get folded just right, they're disassembled and their components are reused. So I'm going to take 7 words on the screen here, and I'm going to, quote, fold these as best I can. I'm going to stack them on top of each other. And when we stack them this way, you're going to notice there's an additional piece of information going up and down, the word success. Now, if you don't fold these just right, or again, if we make some random mutations, change letters, duplicate things, delete things, we're going to lose that piece of information. Random mutations are not going to make it better. They're going to make it worse and worse. So if we don't stack them right, they get shifted around, and we just destroyed our additional piece of information. So what we see in conclusion here is that certain things might look great from a certain distance or a certain angle, like that bright red BMW. We envisioned opening the hood to see the beautiful engine. Well, we opened the hood on evolution and we found out the engine truly is missing. There's nothing to drive evolution. Here's an interesting quote from a geneticist. He said, "Genetics has no proofs for evolution. It has trouble explaining it. The closer one looks at the evidence for evolution, the less one finds of substance. In fact, the theory keeps on postulating evidence and failing to find it, moves on to other postulates, fossil missing links, natural selection of improved forms, positive mutations, etc. This is not science." Now, we've got one more quote for you that you probably are familiar with. That's Genesis 1:1. "In the beginning, God created the heavens and the earth." The more we take a look at science, the more sense it makes to me that there is a God, there is a creator, and that he created things just the way he told us in the book of Genesis, which gives us a lot more confidence that we can trust Scripture from cover to cover. So I hope that you were encouraged by this particular talk. And again, this is not about trying to disprove evolution or prove creation. This is ultimately about the authority of God's Word, that it is trustworthy from cover to cover, and that you can certainly trust its gospel message about having our faith in Jesus Christ for our salvation. Not about working hard and being good enough, or about not believing in evolution. It's about placing our trust in Jesus Christ and the authority of His Word. So we appreciate you spending this time joining us for this particular presentation. Hope to see you in future talks. God bless.